This lecture is on an interesting result. It is on the derivation of the quadratic formula, and it involves completing the square. So we start with the quadratic function here, ax squared plus bx plus c equals 0. Alright, and we're going to complete the square using the letters a, b, c, and not numbers as before. The procedure will be the same. The first thing we do is say, we don't want that. We want the coefficient of x squared to be 1. Right now it's a. A can't be 0 or we'd have a linear equation. So let's divide both sides by a. When I divide the 0 by a, I still get 0. C divided by a is the c over a term, and now bx becomes b over a times x. Just like in completing the square with numbers, I have a constant here. It doesn't depend on x, it's just c over a. I take and move it to the other side. Then I look at the coefficient of x, which is b over a, and divide it by 2 and square it. Then I get the term here. Now I add this term to both sides of the equation. That's our completing the square. That will make a perfect square on the left-hand side. So previously, here's what was on the left-hand side. Now I add that extra term, and this is what I get on the left-hand side. Of course, I have to add it to the right-hand side, and I get this. I've repeated the last equation from the previous slide onto this slide, so you don't have to remember anything. So we're looking now at the left-hand side. This is a perfect square, so I'm going to write it as a perfect square, and here it is, x minus b over 2a squared. On the right-hand side, I'm going to put everything over the common denominator of 4a squared, and so I get b squared minus 4ac over 4a squared. The next step is to take the square root of both sides. When I take the square root of x plus b over 2a squared, I just get plain old x plus b over 2a. On the right-hand side, let's leave the square root in because I can't factor anything out except for the denominator. So I could write this as plus and minus square root of b squared minus 4ac, which you recognize as the discriminant, over 2a. Now isolate x by moving the b over 2a to the opposite side, and now we have here the quadratic formula. So now you see that the quadratic formula is just the result of completing the square using the ABCs, and after that you just plug into it and you don't have to complete the square again. Hope this takes a little bit of the mystery out of where the quadratic formula comes from.